All right, so once again, we are given this polynomial function f of x, and here it's its equation, and we need to find its roots. That is, we need to find all of the x values that are going to make this whole thing 0. That is, when we replace all of these variables with that specific x value, that specific number, when we evaluate this expression, we get 0. So we're looking for all the x values that will make that happen. Now note, we are given, free of charge, the fact that x equals -2 is a root of this polynomial function. So I leave it to you to confirm that if we substitute x equals -2 in here and we evaluate that expression, indeed, we're going to end up with a value of 0. And so when we think about this equation's graph, we already know that we're going to have an x-intercept right there at the value -2. But what about the other ones? Well, here's my claim. Knowing that x equals 2 is a root, I claim that we can write or rewrite our function f of x as x plus 2 times something. Why? Well, if we were to actually plug x equals -2 into this function, well, I think we'd have -2 plus 2 times something. Well, right here, that's going to be 0. And 0 times anything is 0, so that confirms that x equals -2 is indeed going to be a root of our function f of x. Well, how are we going to find what this remaining part is? Well, we're going to have to do some polynomial long division. And we're going to need to divide this whole thing by x plus 2. So let's go ahead and get ready to do some of that polynomial division. So what I'm going to do is I'm going to kind of set that up down here. So here is our original polynomial. And I'm going to put it in a kind of long division hut. We've got an x plus 2. Outside. Okay, here we go. So my first question to myself is, well, what must I multiply x by to get x cubed? And I think I got to multiply it by x squared. Now I'm going to multiply x squared by our whole divisor, and we're going to get x cubed plus 2x squared. And I'm of course going to subtract this entire quantity from our big dividend. And we get, well, 0 here. That's good. And I think we get -6x squared. I'm going to bring this minus 9x down. And so my next question to myself is, what must I multiply x by to get -6x squared? I got to multiply it by -6x. So note, we are en route right now towards finding what this remaining part of the equation is, or our polynomial's equation is. So I already know I'm going to have an x squared and a -6x. We can go ahead and write that down here as well if we'd like. I'm going to say, okay, well, I'm going to go ahead and I'm going to take this, my -6x, I'm going to multiply it by our entire divisor, and we end up with a -6x squared. That's good. And let's see, -12x, I believe, right? 6x, -6x times 2, yep. So I'm going to subtract this entire quantity. I'll do it in red to make sure we don't forget. And we end up with a 0 here. That's great. And a positive 3x here, I believe. And I'm going to bring on down this plus 6. Okay, and now I'm asking myself, well, what must I multiply x by to get 3x? Well, I think I got to multiply it by 3. So I'm going to toss the 3 up here in our quotient, and I'm going to then, of course, multiply it by our entire divisor. And we end up with a 3x plus 6. And again, thank God, we got a remainder of 0, which is very good. If we got a remainder that wasn't 0, we'd be a little bit concerned. And so, here we go. We have found exactly what we need to complete these factorized versions of our polynomial's equation. So a plus 3, if you will. And I'll toss it in here for good measure. All right, so I'm going to rewrite this whole factored version just a little bit to the right. It's just we have a little bit more room on our hands. So our function f of x we can now rewrite as x plus 2 times the quantity of x squared minus 6x plus 3. Well, we're trying to find our roots. Remember, that's the whole idea. So to find our roots, we want to find what x values make this guy equal to 0. So here we go. 0 equals x plus 2 times the quantity of x squared minus 6x plus 3. Now here's the deal. unlike the other example that we did, you know what? I'm looking over here and I'm thinking, you know what? This isn't going to factor, at least not nicely. So I'm going to take this one step at a time, and I'm going to say, well, I know, for instance, that x equals -2 is one of our roots. I mean, we were told that in the first place. What we need to do is say, well, if this whole statement is true, that 0 equals the product of these two things, well, then either this one must be 0, aka x is -2, or this guy must be 0. So I'm going to set up another equation. I'm going to say 0 equals x squared minus 6x plus 3. And I'm thinking, okay, now we got to solve this by completing the square. So here we go. I'm going to get that 3 out of there, take it to the other side. So we got our new equation, -3 equals x squared minus 6x. I know that we're going to have to add something here in order to make this a perfect square. That something is a 9. And of course, what I do to one side of an equation, I certainly have to do to the other. And so over here, I think we've got the perfect square, x minus 3, quantity squared. And on the left-hand side, we've just got 6. Okay, I'm going to take the square root of both sides, and I think I end up with the right-hand side's not so bad, x minus 3. And on the left-hand side, I think we're going to have plus or minus the square root of 6. And so I think that when all is said and done, our other two roots are going to be 3 plus the square root of 6 and x equals 3 minus the square root of 6. So man, you got two more roots there. And what are these going to look like graphically? Well, I consider the square root of 6, I'm thinking it's somewhere between 2 and 3. Because the square root of 4 would be 2. And the square root of 9 would be 3. So 3 plus something between 2 and 3 is going to be around between 5 and 6. So I think we're going to have an x-intercept somewhere between 5 and 6. I'm going to eyeball it right there. And of course, if I subtract something between 2 and 3 from 3, I'm going to get something between 0 and 1. So I'm going to eyeball it right there. I have no idea what this graph is actually going to look like. But those are going to be our 3 x-intercepts. That much I know. By the way, it's really helpful to take that information, what our roots are, and actually use them to write a fully factored version of our equation there. And so what I think we can rewrite our function as is, well, x plus 2 times the quantity of x minus 3 plus root 6. Note those double parentheses, and of course x minus, well, our other root, 3 minus root 6. And just to kind of clean things up a little bit, I'm going to go ahead and distribute these two negative signs. So I think our fully factored version of our parabola is x plus 2, x minus 3 minus root 6, x minus 3 plus root 6. And there is our fully factored version of our parabola. And we have found our roots. I guess that's what we were eventually looking for. Of course, we knew -2 to begin with, but 3 plus root 6 and 3 minus root 6. So let's go ahead and actually take a look at what the graph looks like. So the first one we'll use is the actual graphing calculator result. So if you go ahead and you were to insert that equation into your graphing calculator, you find, oh, here we go. Here's an x-intercept at -2. Here's an x-intercept between 0 and 1. And 1, 2, 3, 4, 5. Here is an x-intercept between 5 and 6. And if it helps at all, here is the same graph that I put on my graphing calculator on the computer and zoomed out a little bit so you could see a little more of it. But once again, we have those exact same x-intercepts at -2, somewhere between 0 and 1, and somewhere between 5 and 6.